Today we're going to do 6.2, describing function. That will be pages 163 to 168 in your book. Your essential question is what characteristics you use to describe a function. I've already put some vocabulary down. If you need to stop the video to copy it, then do so. One-to-one relationship where the input x does not repeat. A linear equation, the graph forms a line. If the input does not repeat, then we can also call it a linear function. Proportional, we've done those before. It goes through the origin, 0, 0, and we have a direct variation equation of y equals kx. Non-proportional means that you have a y-intercept other than 0, 0. It won't go through the origin. And the equation format is y equals mx plus b. At this point, I'm going to start using a copy of the book pages so that we get the examples. And we start with an explore activity, investigating a constant rate of change. The U.S. Department of Agriculture defines heavy rain as rain that falls at a rate of 1.5 centimeters per hour. They've set up a table for us. The table shows the amount of rain that falls in various amounts of time during a heavy rain. Complete the table. This is our time. This is our hours. And remember, it said 1.5 centimeters per hour. So at 0 hours we have 0 rain. After 1 hour we have 1.5. At 2 hours it would be 3. 3 hours would be 4.5. 4 hours would be 6. 5 hours would be 7.5 centimeters of rain. Plot the ordered pairs from the table on the coordinate plane at the right. You have a coordinate plane here. So 0, 0, have 1.5. In 2 hours we have 3. In 3 hours we have 4.5. In 4 hours we have 6. In 5 hours we have 7.5. Okay? How much rain would fall in 3.5 hours? Well, in 3.5 hours we have a point that's just kind of right there, so it's going to be better than 5 centimeters. So I would say 5.0 centimeters plus. There is a way to figure it out. And guess what? I already did that. Plot the point corresponding to 3.5 hours of heavy rain. It's going to be right there in between those two. Half of 1.5 is 0.75. So I could take my 4.5 and add 0.75 to it, and it would really be 5.25 centimeters. And that's about where I have it. What do you notice about all the points that you plotted? Well, all the points that we plotted, if we pull out our straight edge, should they lie in a straight line? Or to take and draw a line, would it go through all of those points? And I think the answer would be yes. Okay. Is the total amount of rain that falls a function of the number of hours that the rain has been following? Yes. Why or why not? And I would say yes. Because our function is really 1.5x, because for every hour we're getting 1.5 centimeters. So our rate of change is constant. Okay, and that's what we do. I'm going to assign to you the reflect to answer. And then I'm going to turn the page. Now we're going to talk about graphing linear functions. And this is where we talk about a linear equation is where the graph of the relationship is a line. So the equation is a linear equation. It forms a line when graphed. And being as we do have a one-to-one, exactly one value of y for every value of x, the relationship is also a function. So we would call it a linear function because it's a non-vertical line. And if you look at this, it's not straight up and down. It's not parallel with that y-axis, is it? It's at a slant. Example 1. The temperature at dawn was 8 degrees Fahrenheit and increased steadily 2 degrees Fahrenheit every hour. The equation y equals 2x plus 8 gives the temperature y after x hours. State whether the relationship between the time and temperature is proportional or non-proportional. Then graph the function. Well, step 1, it says compare the equation with the general linear equation y equals mx plus b. And being as that is in the form of y equals mx plus b with m equal 2 and the y-intercept being 8, it is a linear equation, but being as b is not equal to 0, then it is non-proportional. And that's something that we've discussed before. Choose several values for the input x, substitute in, and they've already done that for us, and they've even extended it and shown us the exact ordered pairs, which come from the x and y values. This is just a process column. Graph the ordered pairs, which they have done. Draw the line through to represent the solutions of the function, which they have done as well. These are the steps that you have to go through to complete your turn number 2, and that is part of your assignment. Study this very carefully to see what they did. They're saying x, which would be the number of hours, goes in the x. We're going to increase 2 degrees every hour, so we started at 8 degrees. There you go. They're going to give you a different function here. I would do a similar table and determine whether it's proportional or non-proportional and graph it. Next page on 165, determining whether a function is linear. The linear equation in example 1 has the form y equals mx plus b, where m and b are real numbers. Every equation in the form is a linear equation. They can represent linear functions. Equations that cannot be written in this form are not linear equations, and therefore they are also not linear functions. Square tile has a side length of x inches. The equation y equals x squared gives the area of the tile in square inches. Determine whether it is linear, and if so, if it is proportional. And they take you through the same steps that we just looked at. First of all, choose several values for x, 1, 2, 3, 4. Plug them into the function, and this is what this is. This is y equals x squared. So we're going to put 1 in place of x. 1 squared, 2 squared, 3 squared, 4 squared. Work it out. There are the points. Then they want you to graph them, which they've already done here on your graph. You look at this, this is not a straight line. If I take my straight edge, I can't line up all the points on a straight line, can I? So this is not a line. It's not a line. It's a curve. And you can kind of sketch that curve through there. So being as it's not linear, guess what? If it's not linear, we can't say whether it's proportional. Only a linear relationship can be proportional. So the relationship is not proportional. And you have another your turn to do. Again, follow the same steps right here to see what happens. Don't guarantee the answer will be even similar to this, but you'll be able to figure it out. And at that point, you are to the guided practice, and I want you to do numbers 1 and 2. And we'll wait on 3 and 4 until we're in the classroom together. So you have a quick check. Remember, this is the problems that you do at home. And if I go back through those pages, you have page 163, reflect number 1, 164, your turn, number 2, page 165, your turn, number 3, and then page 166, the guided practice, numbers 1 and 2. And that will be, oops, there you go, sorry, I did it off the screen. That is what you need to have done when you come to class tomorrow.